get when you go from the simpler model to the more complicated one. Okay, and we've seen from the theory that the difference between the deviances of the two models has an approximately chi-squared distribution, so we can use that as the basis of a test. Okay, so a table can look like this. So model 1 has its deviance at the bottom, d of y and mu hat star, so star for the simpler model, model 1. And we split that up as a sum of the deviance for model 2, deviance of y and mu hat circle, and then at the top, the difference between the two deviances. And the residual deviance for model 1 has n minus p star degrees of freedom, where p star is the number of parameters fitted in model 1. The deviance of model 2 has n minus p circle degrees of freedom, where p circle is the number of parameters fitted in model 2. And then the difference, which corresponds to the difference between the two models, is p circle minus p star. Okay, and we've seen that in that case, the difference in the scale deviances, these are actually the residual deviances in this column, but the scale deviances we get by dividing by phi, that has a chi-squared distribution, approximately, with that number of degrees of freedom. Okay, next Thursday I will go through an example of doing this for the beetle data, which is example 29 in the notes.